Good afternoon. So it's going to be my challenge to keep you interested in this third panel discussion. I know we're over time and I know you're all hungry and eager to go to lunch, but I would like to ask you to bear with me. Just 1 second. Okay, great. So this was the original agenda for today's for the third panel discussion, and I actually would like to bridge to all the previous panel discussions over to a holistic framework of the harvesters. How can they be used? Yeah. So we heard in the previous panel discussions, yeah, that we have to create, that we have to communicate, we have to interact between different actors developing the harvesters so that they function. And now I'm going to expand this and going even further and look into how policies, how operators, how governments, and how the technical aspects can be integrated in a holistic framework regarding sustainability, so environmental impacts, regarding social aspects, and then regarding some political aspects. Yeah, that's the purpose of our work package. So I would like to introduce also the panel, maybe. So if Marco, if you could join us here. And then we have two panelists that are online. Unfortunately, one person left already, Andrea Di Piazza. He had to leave, but he gave an excellent presentation. I'm going to come back to some of his results. So thank you for coming, Marco. And just, so in the meantime, maybe you can already put the people online, yes? So very shortly to our work package. Yeah, so our work package is really about integrating all the different aspects and seeing how the harvesters can provide the information so to really increase this resilience. Yeah, we heard the term resilience quite a couple of times, but now we want to dig into it. What does it mean, resilience? And how does it connect to the different stakeholders? And how does it connect to the policy that was mentioned in the previous talk? Yeah, the commissioner, the speaker from the commission pointed it out that there are policies. That's what we're trying to do here. Yeah, so we're looking at environmental impacts, we're looking at social economic assessments, and of course the technical aspects flow into this work package. So in principle, we have these three tasks where we look at the environmental impacts and then create a framework that includes all aspects and then upscale it to a pan-European sector. So just to visualize this, yeah, I put up here 3 pictures of 3 case studies. Yeah, in Iceland, we heard it already. We have this geothermal power plant. You can see the pipes going towards the geothermal power plant. So you have a head. So there is energy potential, and if we go into this resilience, into this vortex-induced energy production, here we have the possibility to have self-powered sensors and monitor some of the physical aspects of the flow. Yeah, so this can help increase the monitoring, and through this we increase the resilience. Second picture is from Ljubljana. So there's a small flow in the stream. There we are developing do-it-yourself devices that can be where private people can install it themselves. And of course, perhaps most interestingly, just a few kilometers to the east of Padova is Venice, yeah, with this lagoon. Yeah, we have Moses, you all heard about it. So there you have quite strong currents, 10 meters per second sometimes. Yeah, so here we looked into what is the potential and how can these harvesters be used. Yeah, and that's a bit what we want to address with the panel discussion here. So we already identified some potential barriers and potential enablers. So it's not only technical aspects that can be barriers. Sometimes it's into institutional barriers. Yeah. If one institution owns the network and another institution operates it, and they don't have the same policy, then you have a barrier. Yeah, and that's a bit what we try to identify by talking to different stakeholders and trying to identify enablers, but also barriers. barriers, but also enablers. Yeah, and you can also have stakeholders that work together, and then you have an enabler where you can find positive feedback loops and you create synergies. That's a bit what we're trying to do. So you also have here, we're looking also at the risks. So you have here a table with different risks and the assessment, if it's critical, moderate, or if it's sustainable. And this brings me to the panel discussions that we would like to have here. In the meantime, so to keep you busy and to interact, to make this as interactive as possible, we have a survey where we would like to get your opinion. Yeah, we rely on the different stakeholders. So if you have time, please take a note. I believe the link will also send out. You can scan in this QR code and you can answer the survey that we prepared for you. We will take this into account because there we look. We would like to ask you to give your perception on how these harvesters can be used. It's essential for us to get your opinion as well. So please, if you bear with us for the panel discussions while you're listening to the panelists, you might answer also the survey that was prepared by the people working on this work package. So this brings me to the question of the panel today, to the discussion. Do we have the online participants online? Yes, so we do. Maybe we can make them visible quickly and so that they can introduce themselves.
Okay. I could not unmute myself, so sorry. My full name is Lydia van Vakeridu-Lirudia. You cannot not required to pronounce it. It's a very long Greek name. But I have a double affiliation. I'm working at KWR, which is a big water research organization in the Netherlands, but I'm also a part-time affiliation with the University of Exeter, the Center for Water Systems, which is also a very strong group working on water research. And apart from this, I'm also coordinating the ICT for Water cluster. The ICT for Water cluster is a cluster of over 85, I think now, projects that have to do with water and ICT. It was created in 2012, that means 13 years ago. It's still active and very active also. And what we're doing, among other things, we have action groups. We are preparing every, say, 5 years, what we call the Digital Water Services Action Plan for the Commission, which points out the gaps and the needs for specific actions in terms of research and innovation for the Commission. Now, the Commission usually adopts this and reacts by introducing tasks or in the calls or promoting research or on a specific topic. So, thank you very much for inviting me here today, and I'll be very happy to share my opinions about this very interesting project.
Thank you very much, Lydia, for introducing yourself. We have a second online participant, Jean-Yves Stenwick. Can you introduce yourself very shortly?
Yes, good afternoon, everyone. I hope you can hear me okay. It's a real pleasure for me to join here from Brussels. My name is Jean-Yves Stenwick, and I'm policy coordinator at Aqua Publica Europea, which is a network of publicly owned water operators at EU level. So our members are the public companies that provide drinking water and wastewater treatment services to more than 90 million citizens across Europe. So our association carries out mainly two activities. We do advocacy work, so we bring the voice of public water operators at EU level towards the institutions, the European Parliament, the Council, the European Commission, and we also act as a platform for best practice sharing between public operators, notably on issues linked to smart metering or digitalisation. So very happy to be here with you today.
Good. Thank you very much, Jean-Yves, for introducing yourself. And then we have our local panelists, Marco Schiavon. Maybe you can introduce yourself as well, shortly.
Yes, thank you, David, for the introduction. Thank you for the invitation. My name is Marco Schiavon. I'm a tenure track researcher here in Padova. I'm an environmental engineer, but I'm working in a department of agronomy. The name is very long: agronomy, food, natural resources, animals, and environment here in Padova. My background is on sanitary environmental engineering, so waste management, natural resources, and pollution. So I can bring some experience from also Horizon project I'm involved in. But maybe, I don't know if I can start now.
Thank you very much, Marco. So as you might have realized, none of the panelists here is actually directly involved with the technical aspects of the harvesters. They're all outside of it. And that's exactly what we want to address, because at the end, the harvesters will be used by people that have nothing to do with the technical aspects. Yeah. And this is what a holistic assessment is all about. Yeah. We want to see how the people outside that apply the harvesters and they're going to use them, how they see it and what their perspective is. So I would like to ask my first question. Yeah, we discussed a lot about resilience. Resilience is kind of a buzzword. It's used in many words, and I would like to dig in a little bit into it, and I would like to start with a local perspective. Yeah, because Marco, he's a researcher here in Padova, working with local farmers and looking into it, how the energy transition can work and what kind of parameters need to be censored. So I would like to ask you, Marco, if you hear about this resilience and these energy harvesters that can provide renewable electricity for sensors, how do you see the potential to use energy harvesters to power sensors in your work with the farmers in the agricultural sector?
Yeah, well, talking about low energy consumption, so sensors basically, there are many applications of sensors in agriculture. For example, think about soil moisture sensors or small meteorological stations. There are many farmers nowadays that are graduated people. They are agronomists, enologists, environmental scientists. So they know how to deal with technological stuff. They know how to interpret data, results. And so they are using sensors in their activities, also, of course, to increase the yields, the production of crops, of fruit, and so on. So there are many applications of sensors in agriculture, and I think this is something that is continuously to grow in the future. And besides agriculture, I would like to spend some words also on other potential applications that I don't think they have been mentioned today so far. For example, I'm referring to air quality in general. There is an interest from farmers, animal farmers, to increase the sustainability of animal farms. And when talking about sustainability, they primarily refer to the wellness of animals inside farms. The wellness of animals is anyway influenced by the indoor air quality. And indoor air quality is a proxy for outdoor air quality because you need to exchange the air inside farms. So there is an increasing interest from, let's say, medium to big companies, medium to big farmers to monitor indoor air quality. Not only indoor air quality, also the waste gas exiting from farms. So they are interested in performing monitoring activities like this. And also, still on air quality. In the past, I worked on urban air quality, outdoor air quality. And there are many applications of electrochemical sensors for outdoor air quality, especially in urban areas. The air quality in urban areas is monitored conventionally by fixed air quality stations that are managed by local environmental authorities. These are very limited in number. They are very expensive because they are made of sophisticated instruments and they are not representative of hotspots in cities. Of course, they are located in some critical points like junctions, for instance, but think about the so-called street canyons. Street canyons are streets surrounded by buildings on both sides. The air is trapped basically inside these streets. So these are hotspots for population exposed to air pollutants that are not routinely monitored by local environmental authorities. So the use of electrochemical sensors, which are low consuming sensors, I think the consumption is in the order of milliwatt, something like that. So it's compatible with the energy that can be harvested with devices like the ones that you are studying in this project. And
maybe I just want to point this out. Yeah, this is a completely new perspective. Yeah, because now we're all of a sudden looking at air quality. Up to now, we were only talking about water quality, and now we see that actually the people that would potentially apply those or use those sensors are interested in air quality. So we have to a little bit think about it. Where do we install those harvesters in a flowing fluid so that they can also be used for air quality? Yeah? This is what this work package is about, to find out what the end user is interested in. I'm going to come back to you, Marco. I just would like to take this up on a European level, yeah, because we have our representative from Aqua Publica, Jean-Yves. He is working on the policy of the European Union. At the end, it has to fit into the policy. So, Jean-Yves, I would like to ask you. Yeah, we've seen that on a local level, there is a need for powering low energy sensors. I would like to see hear about your perspective from a European policy level. How do you see the aspect of resilience of energy harvesters to monitor environmental parameters in the water and also in the air, like we've heard before? I think you have to unmute, Jean-Yves.
Yes, perfect. No, it's working. Sorry, I could not unmute myself. So thank you very much for the question. I'm really happy to hear that you've heard that water resilience was kind of a buzzword, because it's also the case here in Brussels and in EU institutions. So it's definitely a topic which is high on the Commission's agenda, and I'm sure that is something the previous speaker from the European Commission in the previous panel mentioned as well. Since in this new mandate we actually have not only a commissioner for the environment, but a commissioner for the environment and water resilience, which shows the stress and the high priorities this has for the incoming commission. In her State of the Union speech, actually, the President of the European Commission, Ursula von der Leyen, mentioned that the Commission would be publishing soon a new water resilience strategy that is expected for early June. And the idea of this strategy is to make sure that water resources are properly managed, that water scarcity, which is very high in Europe, is addressed. This strategy will also be looking at strengthening the competitiveness and the innovative edge of Europe's water industry, and to also help Europe take a more circular economy approach. So obviously the strategy hasn't been published yet, but we know already more or less the ingredients. And I think there are two ingredients that make it for a good recipe for your project. The first one is stressing water efficiency. The Commission is working on making recommendations for member states to push for a water efficiency first principle. And I really think that sensors can help with that, because to make things more efficient, you need data, and good data to base your evidence on. And good policies needs, robust data to take informed decision. And maybe the second ingredient that might be of interest here is the push on digitalization. So we know that the strategy will also be looking at remote sensoring, at artificial intelligence. So I think there is a good hook as well. And 2 days ago, the European Parliament adopted in its Environmental Committee a draft report on water resilience that the Parliament hopes will feed into the upcoming European Commission strategy. It hasn't been fully adopted by the Parliament yet. It still needs to go in plenary, which should take place in May, so next month. But this report also has a strong focus on digitalization and on technological innovation. So it really promotes digitalization and data-centric solutions. And here, sensors could be really useful to sustain this aspect of the Parliament's resolution.
Thank you.
An additional point is that you might also be aware that since January there is a revised urban wastewater treatment directive which is in force. So I'm representing public water operators, and obviously they have to respect rules at EU level on how to treat wastewater. And this new directive introduces also an energy neutrality target for member states that wastewater treatment plants above 10,000 PE will have to reach energy neutrality by 2045 at the national level, with a series of targets have to be reached. And here as well, sensoring and energy efficiency are a key milestone to reaching this objective.
Thank you very much, Jean-Yves. I just want to point out, unfortunately, Andrea Di Piazza had to leave, but he gave a nice presentation this morning, where he showed that droughts will increase in northern Italy. At the same time, population will increase. And this falls in line with the policy of the European Union that we need to digitalize distributed networks, because we need this information, because it's really going to affect livelihood if we have increasing droughts and more water needs. So there really, this falls pretty much in line with Jean-Yves. I want to take this now a level further up to a worldwide level, because Lydia, I believe that your network is working in the entire world. How do you see the policies and the local aspects? What is your perspective regarding water resilience and perhaps also other environmental parameters? And what role could harvesters play, energy harvesters?
Yes, indeed. I'm the director of WaterShare, which I didn't mention before, which is an international, beyond Europe and beyond Europe, knowledge exchange network. But I would like to take a step back, and based on what Jean-Yves has said, yes, indeed. The Commission has been using the word resilience a lot recently, but I'm not sure that the wider stakeholders, across the world, not just in Europe, realize the difference between resilience and the old world we had for many decades, sustainability. Sustainability, I would say, is a subset of resilience. Resilience goes a lot further, because resilience means also that the system, the water system, whatever the water system is, needs to recover from extreme events. And this is very, very important. And now I'm coming also to the project and energy harvesting. The main advantage, in my opinion, of these technologies of energy harvesting and sensors is that they are decentralized. So when we have a major crisis like flooding or whatever, the central system might suffer, but if decentralized parts continue monitoring with sensors, that's very beneficial for crisis management and for recovery from those extreme events. And this is one aspect that this technology technologies can work. I remember many years ago, about 20 years ago, I think, I was in the Netherlands for a conference, and there were the first decentralized systems at the time for responding to flooding. With sensors that operated independently from the central SCADA. And that was revolutionary at the time, and now we see that technologies are generated that allow this, and this is one aspect of the decentralization that will contribute significantly to resilience. And I'm talking also at global level, not just for Europe. It will be also very important for developing countries.
Thank you very much, Lydia. I think it's very important to note, that with resilience, we go one step further than sustainability. So we've heard now a lot of aspects that where there's a need for the harvester. So I want to go back now on the local level, and see what could be potential risks and barriers, Where do you see, I mean, if you talked before about air quality, where do you see a risk that these harvesters that we can install in pipes or in channels, where do you see a risk or a barrier that it can be really useful for you at the local scale when you talk with the farmers and your stakeholders?
Well, talking about agriculture, agriculture needs irrigation, so the availability of water is always a requirement for irrigation, and my concern is about probably the velocity of water in channels, especially in flat terrain conditions. This could be a barrier probably for the exploitation, the harvesting of energy with these devices. The case is different, of course, in mountainous areas, probably due to the slope, the different slope. But this could be a matter of concern, in my opinion. I'm not an expert of water flows in channels, so I don't have any idea of the velocities, but from my personal experience, it could be low and also variable over the year, depending on water availability. So this could be a potential barrier for these applications.
Yes, thank you very much. Do we have Jean-Yves? Is he still online or? Okay, so Lydia, is she online? Or
I'm here.
yes, okay. So Lydia, I mean, because you, from a global perspective, you heard it on a local scale, that there's this risk that you don't have enough flow. How would you see the risks or the barriers for the implementation of energy harvesters to digitalize water and energy systems? What from your perspective, from a global perspective, how would you what barriers or what risks do you see?
Well, I'm going beyond the technical requirements. I'm going to awareness. I'm not sure that the wider audience, audience by audience meaning water operators, water managers, or decision makers that have to do with water systems, know about these energy harvesters. They're not aware that they exist. They're not aware that they can use it. They're not aware of how they can use it. And then, even if they get awareness, there is the second barrier, which is capacity. Do they have the training or the technical training, the operators to use them, to integrate them in their own system? Here we see at global level, even for other types of digitalization, even for platforms, even for SCADA, even for, data management. We see in many utilities a lot of lack of technical capacity. And one other thing we need to keep in mind is that the water sector, by contrast to the energy sector, is very fragmented. In Europe alone, we have 68,400 different utilities. And some of them are big and big organizations and go to big cities, but a lot of them are for small communities where the decentralized systems would be more useful, but there is no capacity to implement or use them. So to me, the biggest barrier is awareness and then capacity, technical training.
Thank you very much, Lydia. So this is a pretty strong statement. We have actually over 60,000 stakeholders or systems where these harvesters could be applied. So it's a huge potential, but it's also pretty challenging because probably we looked at 7 case studies within the H-Hope, and it was already challenging to find out what are the barriers and what are the enablers and what are the risks. And now if we scale this up to the Europe, there's a huge potential, from a technical side. But then if you dig into the specifics, it becomes quite challenging. So I'm looking a little bit at the time. How are we doing with time? So since we're a little bit behind, and I think you're all very hungry, I would like to thank all the panelists. Yes, maybe Jean-Yves. So we were just discussing before on a very local scale, on a global scale, the risks and the barriers of implementing the energy harvesters. Maybe from your perspective, how do you see this from a European strategy perspective? How do you see what could be the main risks and barriers for the implementation of energy harvesters to increase the resilience of water and perhaps environmental monitoring systems?
Yeah, thank you very much for the question. Sorry, I had a technical glitch, so I had to come back. But I was lucky enough to hear what Lydia said about capacities, and I think I would echo that. It's not only capacities, it's maybe skills shortages in the water sector. I mean, all members, water operators are desperate for finding the right people with the right skills. And so training would definitely be useful to ensure an uptake of these technologies. Because having technologies available is great, but if you have the skills within the operators to use them, then it's really a missed opportunity. I'm not sure fragmentation is such a big problem in itself. I've heard from Lydia that it might be, but definitely the skill shortages and the strengthening of capacities would pose an obstacle to an uptake.
Thank you very much, Jean-Yves. So due to the time constraint, we're going to close the panel session now. I would like to thank Lydia and Jean-Yves. Maybe there's a short question from the audience. Anyone has a question to the panel speakers? If there's no question, then I would like to thank everyone. Marco, also, thank you very much. Thank you for joining us. Best greetings to Belgium and Netherlands, I believe. Is that correct?
I'm in the Netherlands, yes.
So thank you very much. And then I would like to ask the technical assistants to put up the last slide. So because really the audience, we would like you to answer the survey to get your perspective for to identify the barriers and the enablers also that your perspective can flow into the research results as well. So we would need to put up the other slide from the panel discussion. The slides from the panel discussion. Exactly. So here you have the QR code. If you during lunch, we would be very grateful if you could scan in and fill out the survey. And thank you very much for joining us. And enjoy your meal. Beautiful Italian food. We're all looking forward to a great lunch. Thank you very much.